Port scanning. In order to know what is port scanning, first you need to know what is a port. Every IP address consists of a list of ports. So these ports are used to send or receive the data from one IP address to other IP address. For example, if A wants to send some files to B, so first FTP port of A connects to FTP port of B, and then A starts sending files. Every port has its own feature, like SMTP port is used to send mails and POP port is used to receive the mails. So the main use of ports is to send or to receive the data from one IP address to other IP address. Port scanning. The term port scanning refers to the technique or attempt to identify open ports and available services on a network host. It can be used by security professionals to audit network computers to check vulnerabilities. It can be also used by attackers to check victim hosts for possible exploits. So port scanning is a way of figure out which ports are listening and accepting connections. Since most services run on standard document ports, this information can be used to determine which services are running. Overview. Essentially, port scanning involves sending a message to each port, one at a time. The kind of response received indicates whether the port is in use and can therefore be probed for the weaknesses. Objectives. Port scanning is usually used to search for one or more of the following. The host or hosts alive on the target network, the TCP or UDP ports listening on the target host, the operating system running on the target host, the services or applications running on the target host, the vulnerable software versions of the target host. So these are some of the main objectives of port scanning. Types of port scanning. TCP type of scanning. In TCP type of scanning, the client sends a TCP packet containing SYN flag to all ports, one by one, on the remote host. So if the port is open, the remote host replies with a TCP packet containing ACK flag and SYN flag. So if port is closed, the remote host replies with a TCP packet containing RST flag and SYN flag. UDP type of port scanning. In UDP type of port scanning, a UDP datagram is sent to each port on the target host one by one. If the port is closed, then the remote system sends a port unreachable ICMP error message. If the port is open, then the host does not send any error message. Differences between TCP and UDP types of port scanning. The main differences between TCP and UDP types of port scanning are TCP packets are faster, but UDP packets take much time to scan. Both TCP and UDP packets are easy to implement. TCP packets show accurate result, but UDP packets does not show accurate result. Firewall detect TCP packets very easily, but firewall takes time to detect UDP packets. So these are some of the main differences between TCP and UDP types of port scanning. SYN scanning. SYN scanning is other form of TCP scanning. Rather than the use of operating system network functions, the port scanner generates raw IP packets itself and monitor for response. This scan type is also known as half-open scanning because it never actually opens a full TCP connection. The port scanner generates a SYN packet. If the target port is open, it will respond with a SYN ACK packet. When the target port is closed, it will respond with a RST packet. ACK scanning. This is one of the unique type of port scanning, as it does not exactly determine whether the port is open or closed, but determines whether the port is filtered or unfiltered. This type of port scanning is especially good when attempting to probe for the existence of firewall and its rule set. FIN type of port scanning. Firewalls are generally scanning for and blocking packets in the form of SYN packets. But FIN packets are able to bypass the firewalls with no modification to its purpose. Closed ports reply to the FIN packet with appropriate RST flag, whereas open ports ignore the packet on hand. This is one of the typical behavior in FIN scanning due to the nature of TCP. Other types of port scanning. Vanilla, which is an attempt to connect all ports. Stove, which is an attempt to connect to only selected ports. Stealth scan, which is an attempt to prevent the request for connection being logged. FTP bound scan, which is an attempt to disguise the cracker's location through an file transfer protocol server. Fragmented packets, which is an attempt to scan by sending packet fragments that can intrude the simple packet filters in a firewall. UDP, which specially scans for Open User Datagram Protocol ports. Sweep scan, which scans the same port on a number of computers in a network. Sweep scan is also known as port sweeping. Some technical writers in security industry insist that there is a difference between port scanning and port sweeping. They observe that the port scanning is the action of searching a single host for the listening ports, but the port sweeping is the action of searching multiple hosts for a particular listening port. Their conclusion is that port sweeping is often used in identifying a specific service. Example, port sweeping can be used for SQL injection to search hosts having TCP or UDP port 1433 open. Services files on Windows. For Windows system, the port number for common applications are usually recorded in the service files located under System Drive, Windows, System32, Drivers, etc. Open your System Drive, then Windows, System32, Drivers, etc. and Services. Right click on it, open with Notepad. Here you can see the port numbers for common applications.